parabolas can be kind of tricky. There are a lot of steps involved, so let's do a few more examples together. We're going to take a look at number 8 on page 6 of your packet. The first thing you want to do anytime you're graphing a parabola is identify your A, B, and C. And we'll find those numbers straight from our quadratic equation. Remember, A is the number in front of x squared, in this case -1. B is the number in front of the x term, and C is the constant all by itself. So in this one, our graph, or our A value is this number here in front of x squared, which is just -1. Our B value is in front of x, which is +2, and our C is the constant by itself, +2. Now, because A is negative, this graph is going to open down. Because A is 1, that means it's a normal graph, so it's just going to be normal. Now, with a parabola that opens down, it's going to open like this. It's going to look like a mountain, so our vertex is going to be a maximum value. And remember, we go through all these things just to kind of see, okay, what is this going to look like when we graph it? Because it's a good idea to have an idea of what you're going to be headed for. All right, so let's go ahead and find our vertex using our formula, -b over 2a. So b is 2, so -2 over 2 times a, which is -1. Simplify that, -2 over -2, and that equals +1. So that's the x value of our vertex. It's also going to be the number for our axis of symmetry because the axis of symmetry goes straight through the vertex. But we need to find the y value because right now we don't really have a point that we can plot. We just have an x value. We need to find the y half of the vertex. So what I'm going to do is I'm going to use my original equation and I'm going to plug my x value back in here. Okay, so watch how this works. We're going to do y is going to equal, let's see, -x squared. So negative, and instead of x, I'm going to use 1 squared plus 2x plus 2 times x, but instead of x, I'm going to plug in a 1 plus 2. Now I can use my order of operations to simplify this. So 1 squared is 1 times negative is just make it -1. +2 times 1 is +2, and then +2. So this equals 3. That's my y value for my vertex point. So my vertex is at 1, 3. So I'm going to go over 1 on the x-axis, and I'm going to go up 3, 1, 2, 3 on the y-axis, and there's my vertex. And remember, that's going to be the maximum value. So that's the highest this graph is going to be. So I need to find some more points. So looking at the fact that my axis of symmetry goes straight down through that vertex, I'm going to choose 2 points, both of them to the right. So starting here, I'm going to go over 1, which is at x is 2, and then over again to x is 3. And I want to see what are the points for this graph if x is 2 and if x is 3. So to do that, we're going to plug it in. So I'm going to, again, use my original equation, and it's just wherever I see an x, I'm going to plug in a 2. So let's do that. We have y equals -2 in parentheses squared plus 2 times 2 plus 2. Again, just plugging in a 2 wherever I see an x, and be sure to use your parentheses or your order of operations will throw you off. So 2 squared is 4, with the negative in front is -4. +2 times 2 is +4, and then +2. So if I simplify all of this, I end up with 2. So there's going to be a point at 2, 2. So over 2 on the x-axis, up 2 on the y-axis, there's my point. What if y equals, or what if x equals 3? Let's see, y equals -3 squared plus 2 times 3 plus 2. Again, I'm just using my original equation and plugging in 3 wherever I see an x. Let's go ahead and simplify. 3 squared is 9, with a negative, makes it -9. +2 times +3 is +6, and then +2. If I simplify this, it becomes -1. So that means there's a point at 3, -1. So on the x-axis, I go over 1, 2, 3, and then I go down to -1 on the y-axis, and there's my other point. Now, the great thing about parabolas is that they are symmetrical, which means one half of the parabola is equal to the other half. So I can take, if I know that there's a point here that is one space away from my axis of symmetry, then I can go one space away on the other side, and there's a point right there. Down here, if this one is 1, 2 spaces away, then I can go 1, 2 spaces away, and there's a point there. So now I have all 5 of my points, and I can connect them with a smooth, rounded curve, arrows at the bottom, and there's my parabola graph. Let's take a look at another example on the next page. This time, let's take a look at number 14. 14 looks kind of humongous, but it's going to follow the same procedure. So let's see, we'll do find A, find B, find C. Okay, in our quadratic equation, A comes before x squared, so in this case, A is 2. B comes before the x, in this case, it's 12. And C is the constant at the end, in this case, 15. So A is positive, which means this will open up. A is not a fraction, so it's not fat. It's not 1, so it's not normal. So the only other option is a narrow or skinny graph. And then if it opens up, that means my vertex will be down at the bottom, and it will be a minimum. So that's a minimum. Let's go ahead and find our vertex starting point, our x value of our vertex, using our equation. Negative b over 2a. So negative b is 12. Negative b over 2 times a, which is 2. So this is going to simplify to negative 12 over 4, which is going to simplify to negative 3. So the x value of my vertex is negative 3. That's also the equation for my axis of symmetry. Now I need to find the other half of that point. I need to find the y value. So I'm going to take this negative 3 and I'm going to plug it back in wherever I see an x. Okay, so watch how I set this up. I'm going to do y equals 2 times negative 3 in parentheses squared plus 12 times negative 3 in parentheses plus 15. Notice I'm using parentheses wherever I plug it in. That's important to make sure that you don't get confused when you do your order of operations. Negative 3, negative 3. So let's go ahead and plot that. We go 1, 2, 3, 1, 2, 3. Oh, I almost went the wrong direction on my x-axis. So glad I realized that. Let's go to the negative on the x-axis. 1, 2, 3. There's negative 3. And then down 3 on the y-axis. And there's our point. And it's going to be the smallest or the lowest point on our parabola because our parabola opens up. So let's see, our vertex is at negative 3, negative 3. Our axis of symmetry goes right through the vertex. So I know whatever it does on the right, it will also do on the left. So I'm going to choose 2 points going to the right of my axis of symmetry, which means I'm going to go, let's see, if I go to the right, this is negative 2. So I'm going to try negative 2. And so that was over 1. And then if I go over 2, I'm at x negative 1. So I'm going to try negative 2 in my equation, and I'm going to try negative 1 in my equation to see what y will equal. So let's plug those in. Again, using this original equation that we started with, wherever I see an x, x here, instead of x, I'm going to plug in a negative 2. So y equals 2, parentheses, negative 2 squared, plus 12 times negative 2, plus 15. So negative 2 times negative 2 is 4, times 2 is 8. Positive 12 times negative 2 is negative 24. Sorry about that. Negative 24. And then positive 15 just stays positive 15. So let's see, if we add this all together, we've got negative 16 plus 15 is negative 1. Negative 1. Okay, so that means that at x negative 2, y negative 1, there's a point. And that fits with my prediction that it's going to open up and it's going to be narrow. So I think I'm on the right track here. Now let's plug in negative 1. If y equals 2 times negative 1 squared plus 12 times negative 1 plus 15. Okay, so negative 1 times negative 1 is just positive 1. Times 2 is just 2. Positive 12 times negative 1 is negative 12. And then plus 15 stays plus 15. So 2 and negative 12 gives me negative 10, plus 15 gives me positive 5. So that means there's a point at negative 1, 5. So let's see. Negative 1, 1, 2, 3, 4, 5. And that fits with my prediction that it's going to open up and it'll be a narrow graph. So far I know I'm on the right track. Let's go ahead and reflect it. Here, this is one space away from my axis of symmetry. So I'm going to go one space away on the other side. And there's a point right there. Up here, I'm 2 spaces away from my axis of symmetry, so I'm going to go 2 spaces away on the other side. And there's another point. Connect it all with a smooth graph, a smooth curve. Round it at the bottom and arrows on the ends. And you have a lovely parabola. I hope that graphing parabolas is becoming a smidgen easier, but check out the next video if you need another example or two.